let's start with day 17 of Advent of Code. We are working with Chronospatial computer, which is a computer which is a 3-bit computer with numbers ranging from 0 through 7. And it has 3 registers called A, B, and C. And those are special because they can hold any value and not limited to 3 bits. So any integer goes. There are 8 instructions, each identified by a 3-bit number, and each instruction has also an operand which it works with. So now, instruction pointer identifies the position in the program from which the next opcode will be read, which starts at 0 and points at the first 3-bit number in the program. And except for jump instructions, the instruction pointer increases by 2 because it moves over the instruction and the operand that it works with. So if the computer tries to read an opcode past the end of the program, it halts, so it ends there. So that's just a description of how it works. And now the operand, the instructions. So add V is division, opcode 0. The numerator is in the value A of the A register, and the denominator is found by raising 2 to the power of the instructions combo operand. So operand of 2 would divide A by 4. 5 would divide A by 2 by 5. This is odd there. Why B? All right, because 5 represents the register B. So operands 0 through 3 represent literal values, and then 4 is A, 5 is B, 6 is C, and 7 is reserved, will not appear in a valid program. Then we have instruction bitwise OR, bitwise XOR. So that calculates the bitwise OR of register B and the instruction's literal operand. So then stores the result in B. BST calculates the value of its combo operand modulo by 8, so keeping the lowest 3 bits. And then writes the value into B register. Jump not 0, so it does nothing if A is 0, but otherwise it jumps by setting the instruction pointer to the value of its literal operand. So if this instruction jumps, the instruction pointer is not increased. Okay, so it divides XOR of register B and C. So that's 4 of code. Basically, there's various instructions. We will read in the program, and then we should process it, run it, and see what happens. So by giving it some input of initial values in the registers and the program, our goal is to determine what the program will output. So once it outputs something, we will get this, join the commas, remove the commas in the output, and get the final string that was the output of the program. So what I will do is actually I will this time take the program here and try to kind of translate this program into C# code instead of processing it. This is a single input, and we can just make this into a actual C# code that will run instead of parsing it, because that's super easy in this case. So I will take the code. Well, actually, let's do this, and I'll put it there. So this will be the input. So I will do something like private string execute, and as an input I will have A, int B, int C, and then I will have the program itself that will run on that input. So let's translate the instruction. So 2, 4 is the first instruction. So 2, 4, instruction 2 is the BST. So it takes the comp operand, so that's a 4 in this case, so A, and does module of that value. So 2, 4, that's the first one. So 2, 4 is gonna be B equals A modulo 8. So that's yes. So because 4 is A, it means that's module. Then 1, 5, so BXL, 1 bitwise or XOR of register B and the instructions literal operand. So that's gonna be a literal. So 5 will be literal operand. So let's see. Is the operand itself? Okay, so yeah, combo operand is something else. So this one uses literal operand. Okay, so this means that it's gonna be B module B XOR 5, right? Yes, so 1, 5. Then we have 7, 5. 7 is CDV instruction. And ADV is doing combo operand. So 7, 5 means C and B. So it's gonna be working with C register. So C equals A divided by the combo operands. So 2 to the power of B, right? So because it's 5, it's going to be B. So A equal divided by 2 to the power of 5. So it's basically math of B to the power of, or 2 to the power of B. So that's the value which we'll be going for. And then it's gonna be 1, 6, which is one is BXL bitwise OR with the literal operand. So 1 x, yes, 6. So that's gonna be B 6, right? Then we have 4, 3. So 4, 3 will be BXC bitwise OR and register C and stores the result in B, and it ignores the operand itself. So there is the free operand is ignored, but it's 4, so it's B XOR C is stored in B. B XOR C stored in B, and then we have, what is there? 5, 5. So there's gonna be out instruction. So 5 takes value of the combo operand and outputs that value. So 5 is B, so the output B. key new. So that's the output. So let's do output. We do output append, and that's gonna be value of the combo operand, which is B, right? So we output B modulo 8, and we output that as a number. So it's gonna be to string just to make sure, but it should be fine. And then we will do, so it's 5 5, then 0 3 0 3 0 3 performs division. So that's 0 3 with combo operand 3, but that's a literal value in this case. So it's going to be a divided by 2 to the power of 3. A divided by 8 to the power of, right, 2 to the power of 3. Yes. So that's this one. And finally we have 3 0, which means jump. Okay, so it's going to be jumping to the beginning here if a is not 0. So it's going to be do while a not 0. So this is the program, I think. And ultimately, we return to string this way. Okay, so we execute with number of this 0 and 0. That's our output. Now we'll see what happens. Hopefully I didn't make some mistake in the translation of the program, but it's very possible, so we'll see. Right. Let's go what happens. 17, day 17, and we will run it. Well, we actually run it with test data, and this is the output. That's the number. That's not right. Okay, so let's verify what was happening. All right, so it was, yes. Yeah, that seems okay. So I will go back in here and verify my code. So 2 4 would be 2 combo operand by 4. So it should be 4 modulo 8. So B equals 8 modulo A modulo 8. Yes. Then we have 1 5, which is 1 5. Just checking this one. Okay. 1 5 is XOR. So calculate bitwise XOR of B and the literal operand. So B equals B XOR and B XOR 5. Yes, that's correct. B XOR 5. Then we have 7 5, which is CDV. So it's the same as ADV. Division. So it's 7, 5, right? So 7, 5, which is C equals A divided by C equals A divided by value of B. So it's going to be 2 to the power of B, which is correct. Yes. So this is nice. C to the power of B truncated to an integer and then return to the A register. That is okay. Yes. Okay, so that's fine. And we have 1, 6. 1, 6 is BXL bitwise OR with literal operand. So B equals B XOR 6. Yes. Then we have 4, 3, which is BXC bitwise OR and C. So B equals B XOR C equals BS. Then we have 5, 5. So we output B modulo 5. Yes. Then we have 0, 3, which is A equals A divided by 3, which is literal value, right? A divided by 2 to the power of 3. 2 to the power of 3. Yes. And then jump not 0, which is 3, 0. Jump not if not 0. Yes, it seems okay. So what is the problem there? Huh. Let's do plus comma, so I see the values that are output. So that could be that we are overflowing somewhere. 2130. So that could be that we're overflowing somewhere. So I can try to do long just to make sure that it's not happening. No, that's not it. So what is the problem here? Because this looks fine to me at least. So what is the problem? So what was the output there? Huh. Nothing useful. So what am I doing incorrectly? Oh. Yeah, okay, so we have to output with the commas. I see. Okay, that makes sense. All right. So we actually do embed the comma there, and that should be part of the output. So remove output length -1, 1. So we remove the last comma, but that should be, this should be output. And, oh, right. 1 second to wait. Okay. Now, that's correct. Oh, okay, so that was useless. So I spent just a little bit too much time debugging it when the output was actually reasonably simple. So that is part 1 done. Let's see what happens in second part. For part 2, I have to admit I spent some time thinking about this to know what I will be doing, because this is quite a complex one. The goal here is that given the input, we have to figure out the value for register A that will make sure that the output of the program will be a copy of itself. So we are basically building a Quine. So it's a Quine program. That's a special kind of program that outputs its own source code as its only output. So that's the goal of a Quine. And we essentially are tasked to do this in this second part. So given the program, we need to make sure that the value of register A is such that the program will output the same series of numbers as the program itself. And that we will try to do here. So let's open this. So here is our part 2. So it's a copy of what I've done for part 1. I haven't yet solved it, but I think I have an idea how to approach it, because the idea here is that the program itself that we have here is built in such a way that the value from the register A, B and C are both calculated during the one execution of the program. So in the inside of the do-while loop, we actually calculate the value of B here, and we calculate the value of C. So it doesn't matter what are the initial values of these two. So basically you can just leave them out completely and just initialize them here. So we can do long B equals 0, long C equals 0, because it's going to be always 0 initially, and they will be calculated during the do-while loop. So essentially, even we could do this here, because the value will not be is initialized here, and for the next execution of the do-while, it will stay. It will be reset basically. So this is okay. Now for A, it is important to notice that A, the calculation, the program itself works with the remainder of the remainder by after division by 8. So that's gonna be the B value, and then it's using A as well here to divide it by 2 to the power of B. But after one run of the do-while loop, it divides A by 8. So basically cuts off the last 3 bits of the number and continues. So essentially what we are doing here is for every run, we divide the number by 8. So the first output number depends only on the, well, basically we can kind of build up the output starting from the end of the number. So, well, starting from the, let's see. So basically, if we get the input itself that we are talking about, so this is the program that we're executing. So we need to get the first number. The do-while loop will run once, then divide the number by 8 to process the second number, and so on. So we always get one of the numbers in the output during each run. So if we start from the end, this is the last number that will be output before A becomes 0. So if we figure out what number is needed to get A to get this value of 0, so it's going to be something between 0 and 7, because 8 would be, the 8 would mean that the next value would be non-zero, still be non-zero, and we would have another run. So we basically need to figure out which of the inputs between 0 and 8 and 7. So A will be equal to something between 0 and 7 to get the 0. And when we get it, then we can just multiply that number by 8 and do the same thing to get the value of 3. So we will do, so basically we can call this A0, and we would do then A0 times 8, because that's the previous value that gave us this new A. And then we try this to A0 times 8 plus 7. So one of those will be A1. And so on. So we continue and kind of build up the output from the end, starting with the 0 at the end. So that's the idea what I will try to do here. And we'll see how it works. So I will do expected output. That will be this number split by comma, so we get the expected output, and then we need to figure out what's the value of A. So let's do, I will do u long, because it's going to be a large number. So u long, and then we will do a for loop, starting with int I equals expected. Or actually, what we can do is do it recursively, because the problem could happen that the number that we are, there will be multiple ways to get the output, and I think that they are asking us to get the lowest positive value of A that causes the program to output a copy of itself. So we will do it recursively, so that we potentially can find all the solutions and find the lowest one. So I will do private void solve. Well, it's going to be u long current A. Then it's going to be string. So no, actually we want to have just characters, right? So select C0, because it's going to be single characters. So it's going to be characters, expected output, and we also need to have index. So this is the index that we are processing. So now, if index equals, so if you're processing -1, we are at the end, so we need to make sure that our current result is the lowest one. So private ulong best, it's gonna be ulong max value, and we will just check if best equals mathmin current A, and just return. And now we will try to get the next value. So the next is going to be expected output index, and what we will do is we want to take current A and do, that's basically for reminder less than 8, we will do next A equals current A plus remainder. We will try to run, execute with next A, and we will check if the value that we get from the output ends with what we want to have there. So I need to remove this because we don't have the commas there. But the output from here will need to end with the same text as the expected output. So actually, we can do it this way. We can do join. So, or rather, what we can do actually, just to simplify things, is to have replace in here. We can replace. This is a selection. Where is the selection? Find in selection right here. So we replace this with in the selection. We want to replace all like this. So just a continuous string of characters and string of characters, and we will solve for current A is 0, and we'll solve for expected output length -1. And that's the initial index, and expected output is the string that we are using. So now, or actually we can move it also here. So private output, and this is the value that we want to have there. So that's that. We don't have to pass it in every time. So just to simplify things, so expected output length -1, we run it, and when this runs, yes, I need to remove this now. So when it runs, we can just return next, best to string. So that's going to be the number that we are looking for. So now, expected output index, and we execute, and the result will be if expected output ends with result, then we found potential next step in the solution. So we do solve next next A -1, and we continue. And if it doesn't find, then it tries the next remainder and so on. It might find 2 for the same current A, and then it will kind of branch out and try to solve it in multiple ways. But this should be hopefully enough to solve the problem. So let's see what happens. Okay, so this is the output number. Let's see what happens. Actually, I will also do output equals execute for that large number. Let's just see if it actually handles things correctly. What road is not cooperating, so let's try again. Just to see if it actually does the right thing, and the output will be matching the number, and it is, I think. So that seems pretty promising. So let's try to put that number as the output here. And that is correct. Okay, so that was day 17. Pretty complex one. Got me thinking for a while, so this video was a little bit shortened, but in the end, the solution is not that hard, just requires a little bit of thought to get the right approach, to figure out that you need to build up the number from the end to the lower numbers, to the higher orders of the number, and finally build up the whole thing this way. So yeah, I hope this was useful. I will do another video as usual to see if ChatGPT can figure this out. I don't expect it to be very easy for ChatGPT because it will have to notice this peculiarity about the program itself, which is something that usually is a problem for ChatGPT. So it's going to be interesting to see if it has some idea about this. And maybe for this problem, actually, I should be using ChatGPT 01. So we'll see if 01 can figure it out as well. So thank you for joining this session. I will do the next video for day 18. So tune in to my channel and I'll see you next time.